We're live. So today our notes, what we really want to talk about is a thing called Eulers number. (11-21). So who was Euler? Leonhard Euler was a Swiss mathematician, physicist, astronomer, geographer, logician, like logistics, and engineer who founded the studies of graph theory and topography and made pioneering and influential discoveries in many other branches of mathematics such as analytic number theory, complex analysis, and infinitesimal calculus. Wow. Okay, there he is. What he came up with, what he's famous for, is Euler's number. So what is Euler's number? The number E. And E is equal to, so guys, we did 100, right? We did this already. I did to the 100, I think did right here. I got about a 2.708. And then I got a little more accurate, I did to the 1 million. And I got about 2.718, so the bigger the number, the closer I'm getting to Euler's number. And then we could even do it to the 1 million, or 1 billion, so I can do the, all the way down here. I can go parentheses 1 plus 1 divided by, oh, hold on, there's E, I don't want that yet, clear. Parentheses 1 plus 1 divided by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And you're still not to Euler's number, because that's only a billion. But if you could go to infinity, you'd get the number E. If you go to infinity, you get the number E. So the number E really is this. E is equal to this if x in this case goes to infinity. So here is the number E. So the number E is defined as the limit. And we say the limit because you can't get there. It's a calculus way of saying things. We're going to limit it. We're going to let x go to infinity. So you'd have something look like this, 1 plus 1 over infinity to the infinity. But you can't get to infinity, so we just say we approach infinity. But that is the true definition of E. And there it is, kind of, because like you guys said, it's like pi. We can't see all of it. It goes on forever, so we can only see part of it, right? So, in this case, it would go to 0. And we're going to look at that, okay? If you go to a negative infinity, it goes to 0. Okay? And then you're really getting into calculus, Lauren. I can show you. It's not hard. Okay? Okay, who is Euler? A French he's a Swiss mathematician. Swiss mathematician. And he lived about in the 1700s. And he came up with this cool thing called the number E after himself, right? Now, if you do this one, 1 minus 1 over x to the x, let's see what that is. So if I do a really big number like a billion, let me go 1 minus 1 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. I have about 0.367. So if I do the limit as x approaches infinity of 1 minus 1 over x to the x, this is going to equal e to the negative 1 power, okay? So I'll just do that on my calculator so you can see it. If I go e to the negative 1 power, oh, let's go back. I want to delete that, delete. I want to go to the negative 1 power. So both of these are going to be used, one for exponential growth and exponential decay, because when you're talking about something in science, it's continuous, right? It's continuous. I mean, you don't have to take little coffee breaks, chill for a while, and then come and like thrash your body, right? I mean, it's continuous growth or continuous decay, okay? All right, easy so far? Now, turn the page. So a virus grows continuously. Oh, continuously. What did I tell you? What are we going to use when you see that word? Continuously. What are you going to use? You're going to use the E. So that's our rate. So we learned yesterday, and I'm not going to use this per se, We learned this formula yesterday. Plus or minus r to the t, right? We learned that yesterday. Or we learned this formula, right? This is one that grows with a certain percentage rate, like a banking formula, right? At 8% or 2% or whatever. This is more like a banking formula because you use this for an interest rate. This is like a regular exponential growth rate. Well, we're going to use this formula, but our base is going to be E. So we're going to have A of t, amount over time, is going to equal, we're going to use P E to the R T, okay? Write that down. Some people call that the PERT formula. You can see why, the PERT formula. The PERT, but it is exponential growth, but it's growing continuously, okay? So I'll highlight that. That's a great formula for us to use. So in this example, the virus grows continuously at the rate of 4%, so that's my rate, okay? That's my rate, so my rate is 4%. Beginning population, that's my P. My beginning population is 10,000 bacteria. So it says write an equation to model this. Okay, so I'm going to go A of t amount over time. A of t equals P, which is my beginning amount, 10,000, E, the number E, to the 0.04 t, because I changed that to 0.04, right? Thumbs up? Pretty easy, right? I've got my P is my initial amount, 0.04 is my rate, E is my continuous growth, right? So now we can use this formula. How many are present after 8 hours? So I'd say, okay, well, amount after 8 hours, or A of 8, amount over 8 hours, is equal to, well, we started with 10,000 bacteria, the number E, to the 0.04 times 8. I just plugged 8 in for time, and we're going to use our calculator. Now, before I use my calculator, I want to show a button, okay? There's two E buttons. There's E, which is plain old number E. This one we want to use because it's E to the X, right? This button's better because then you can just automatically put E to the X. Okay, so we're going to use this button here, E to the X button. So I'm going to put this in my calculator. I'm going to write my 10,000. I'm going to push my E to the X button. See how it pops up, E to the X? 0.04 times 8. And it grew. It went from 10,000 to 13,771 bacteria, right? I don't need decimals. It's bacteria, right? 13,771. I guess cells, or whatever they are. What are virus? So it was not even a cell. It's virus. Viruses. There we go. Well, yeah, viruses sounds like more than one type of virus. I'm just going to call virus. Yeah, and virus is not a cell, is it? I mean, you guys know that from biology. Right. Okay, now they also use this in banking. So, in banking, if you did like a credit card, some credit cards will charge you per day. Yeah, can you believe it? Yeah, serious. Yeah, be careful. You get a credit card, be careful, right? So you can do this in one of two ways. One, you could do it using this formula here. So we could go A of t equals my 12,000. 1 plus my rate, 1 plus, this should be R, I'm sorry. That should be R, which is my 0.015 over, now N. N is the number of times I compounded. N is the number of times I compounded. That should be R. In 1 year, how many times do I get to compound my money? Hello? What does it say? It says daily, doesn't it? How many days are in a year? So that thing's going to get compounded 365 days. So it means it's going to be compounded every day, right? Okay, so 365 to the 365 times 10, okay? Let's see if I can use my formula. I got 12,000, okay, so I'll use my calculator, clear that. I'll go 12,000, 1, 2, 3 times 1 plus 0.015 divided by 365 to the power of 365 times 10. So you're going to be having to pay about $13,941 for the year if it's compounded daily. That means they have your money and they keep compounding it every single day, 1/365th of it every day. Now a faster way to do it is this. If you just say, well, 365, if I'm going to compound it every day, let's just simplify it and say compound it every moment. It doesn't change it much, but it's an easier formula. So if we say, well, every day is kind of a hard formula, but we just say, talk about it continuously, which is pretty close to every day, we use the PERT formula. So we'll go A of 10, that should have been 10 also, equals 12,000, oh, 10,000 here. Well, okay, we'll do 10,000. I changed the problem. And I'm going to use my E button. E to the 0.015 times 10. It's a little bit easier formula, isn't it? I have my E button. 10,000. I'm going to use my E button. And I get about $11,618.34. Okay. Not a lot of homework, and we have lots of time. Isn't that nice? Lots and lots of time. Do you guys need a mass break real quick?
Yeah, let's go outside real quick.
Let's go outside real quick. Let's breathe some fresh air.